Okay, so this is a video on question 12, exercise 11.1. N cubed plus 6n squared plus 8n is divisible by 3 for all n and n. So I have to prove this, okay? So, in order to prove this by induction, we're going to say step 1. Step 1 is going to be prove for p of 1. Now, if pn equals n cubed plus 6n plus 8n, what we do with P1 is we replace all n's with 1, so we're going to get 1 cubed plus 6 times 1 plus 8 times 1. Put that into the calculator, we get 15. And then we say 15 divided by 3 equals 5. Hence, P of 1 is divisible by 3. Now, step 2. Assume true for P of k. Such that P of k equals k cubed plus 6k plus 8k, and this is assumed divisible by 3. Assumed divisible by 3. Okay, next one, step 3. Okay, we're going to test for P of k plus 1. Now, P of k plus 1 equals k plus 1 cubed plus, that's k squared, 6n squared. N squared doesn't change the answer, the first one. So 6 times k plus 1 squared plus 8 times k plus 1. Now, what we should do down the bottom is we should figure out what k plus 1 squared is. So k plus 1 squared, when we square that out, it's going to be k plus 1 multiplied by k plus 1. Chance will be k squared plus 2k plus 1. Now, k plus 1 cubed, it's the same thing, except I have to multiply k plus 1 multiplied by k squared plus 2k plus 1. It's basically the answer of k plus 1 squared with another k plus 1 multiplied by it in front. Okay, so get this time k cubed 2k squared plus k squared plus 2k plus 1. It's going to be k cubed plus 3k squared plus 3k plus 1. Now that we've sorted that part out, we're going to put this back into our formula. So, we have here is k plus 1 cubed, so we can see that part there, k plus 1 cubed is this part here, and then we're going to have plus 6 times k plus 1 squared, so it's going to be plus 6 times this number here, k plus 1 squared, k plus 1 squared, and then finally 8k plus 8. Now, we're going to have here is k cubed plus 3k squared plus 3k plus 1 plus 6k squared plus 12k plus 12k plus 6 plus 8k plus 8. So, what we have here, it's going to be k cubed, 3k squared, 6k squared, it's going to be plus 9k squared, and plus 23k plus 9. Now, what we got to do is, out of this p of k plus 1, we got to make p of k. So we're going to pull out P of k. And P of k is k cubed plus 6k squared plus 8k. So look what happens. So we're going to take out the k cubed. We're going to take out 6 of the k squareds. We're going to take out 8 of the k's. Now what this leaves is, it leaves over 3k squared. It leaves 15k left over, because 8k plus 15k is 23k, and it leaves a 9 left over. Now, when I factorise this, it's going to be 3 into k squared plus 5k plus 3. And then the starting off point is going to be k cubed plus 6k squared plus 8k. That's P of k plus 1. Now look what happens here. Now, what happens here is this part here is assumed true by P of k. Just remember, P of k is all the way up here, is k cubed plus 6k squared plus 8k, and that's assumed divisible by 3. And this part here is divisible by 3. 3 divided by 3 equals 1. And this part, so 3 is divisible by 3. So you're going to divide 3 into this 3 part here. So hence, P of k plus 1 is divisible by 3. If P of k is true, hence, by the principle, of mathematical induction, P of n is true. Okie dokes. Okay, so on this one here, P of n ends up to be 5 to the power of n minus 4n plus 3. Now, part 1 is test for P of 1. So test P of 1, where P of 1 equals 5 to the power of 1 minus 4 times 1 plus 3. What that gets us is 4. 4 divided by 4 equals 1. Hence, P of 1 is true. What I mean by true is it's divisible by 4. Now 2. Assume true for P of k. Assume true for P of k. So what we're going to get here is P of k equals 5 to the power of k minus 4k plus 3. Now part 3 is assume a test for P of k plus 1. So P of k plus 1 ends up to be, replace all k's with k plus 1, so it's going to be 5 to the k plus 1 minus 4 bracket k plus 1 plus 3. So we're going to get is 5 times 5 to the power k. That's by that rule there, that's 5 to the power k, 5 to the power 1, or 5 times 5 to the k. Then multiply that out and you get minus 4k minus 4 plus 3. Now what I'm going to do next is I'm going to turn this into minus 1 minus 4k. Then we're going to have 5 times 5 to the k. Now, what I have to do once again is I have to take out p of k. I have to form p of k out of p of k plus 1. So take out p of k equals 5k minus 4k, and then it's a plus 3 at the end, okay? So, what I could have done was, in the last step, I have a plus 3 here, and have a minus 4k here. So I'm going to have my minus 4k and my plus 3. And this is 5 times 5 to the k, so I'm going to change that into I'm going to change it into 4 plus 1. 4 plus 1, 5 to the power k. Okay, because I want it to be once again divisible by 4. So it's going to be 4 times 5 to the k, and then the other one's going to be 1 times 5 to the k, or just 5 to the k. Okay, now we can see this, and then we have our minus 4 at the end. So we're going to redistribute this so that it's going to be 5 to the k minus 4k plus 3 plus 4 to the 5k minus 4. Same thing as 4 times 5 to the k minus 1. You take it out. Now, this is all p of k plus 1. Now, what we're going to have next is basically this part here is assumed divisible by 4. By 4 by p of k. And this one is divisible by 4 as 4 divided by 4 equals 1. So that's all p of k plus 1 into its 2 parts. So therefore, what we have here is hence p of k plus 1 is divisible by 4 if p of k is true okay. Hence, by the principle of mathematical induction, P of n is true. Okay, is that one done? Now, up to number 14. Now, we want to assume that this here is divisible for 21 for all n element m. So we're going to say p of n equals 5 to the power of 2 into n plus 1 minus 4 into n plus 1. Now, part 1 is test p of 1. So when we test p of 1, what we're going to get is 5 times 2. Now 1 plus 1 is 2. Minus 4 times 1 plus 1. It's going to be basically going to be 5 to the power of 4 minus 4 squared. So 5 to the power of 4 minus 4 squared we get there is 609. 609 divided by 21 is 29. So then you can say 609 divided by 21 equals 29. So you can say P of 1 is true, or divisible by 21. Now, part 2, we're going to assume true for P of k. Now, P of k is going to be equal to 5 to the power of 2 into k plus 1 minus 4 to the power of k plus 1. Okay, and then what we're going to have here is we're just going to assume that that's true, and then we're going to go to stage 3, which is test for P of k plus 1. Now, P of k plus 1 means replace all k's with k plus 1, so it's going to be P of k plus 1 is going to equal 5 times 2. Now, k plus 1 plus 1 is k plus 2, and k plus 1 plus another 1 again, minus 4 times k plus 2. Now, what we got to do here is we got to do some indice work. Okay, so we're going to multiply this in here, and we're going to get 5 to the power of 2k plus 4. Now, when we multiply P of k out, it's 2k plus 2. So I need to separate 2k plus 4 into 2 parts. Okay, so it's going to be 5. It's going to be 5 to the power of 2k plus 2 plus 2. And what I can do there is I can say it's 5 squared times 5 to the power of 2k plus 2, because when you add them together, that's the indice, okay? And that's the same thing as 25 times 5 to the 2 into k plus 1. Okay, so back where I started. Okay, and the 4 is, I want the 4 to be k plus 1. So it's going to be 4 into k plus 1 plus 1, which is the same thing as minus 4 to the power of 1 into 4k plus 1. It's going to be minus 4 times bracket 4k plus 1. Now, what we did last time was you make the smaller number from the, you make the smaller coefficient from the bigger coefficient. So we can see here that's 25 and that's 4. So turn 25 into basically 21 plus 4. Okay, so we're going to have here is we're going to have 21 by 5 to the power of 2 into k plus 1, close bracket. Then we're going to have plus 4 into 5 into 2 bracket k plus 1 minus 4 into 4k plus 1. Now we're going to factorize out the 4's here, and we're going to get 4 into, and what we're going to have this time is it's going to be 5 to the power of 2 into k plus 1 minus 4 by that there is k plus 1, for those of you who don't see that. Now the 4 isn't there, so it's going to be 4k plus 1. And that equals 21, 5 to the 2 into k plus 1, close bracket. Now guys, look at this. What we have here is still p of k plus 1, just with a makeover. Now, the first part is divisible by 21. This part here is divisible by 21 as 21 divided by 21 equals 1. This part here is assumed divisible by P of k, because remember what P of k is? P of k is this here, and that's the same thing there. So assumed to be divisible by P of k. So therefore, we have here, so P of k plus 1 is divisible by 21 if P of k is true. Hence, by the principle of mathematical induction, as for principle of mathematical induction, P of n is true. Okay guys, so that is questions 14, 13 and 12. 12, 13 and 14.